All right, there we go. Hi, Enfield Elementary
Hi.
School. It's Mr. H. I'm here with my friends, Mr. Fellman and Ms. Lynn from the high school. And they are physics teachers at the high school. And I was telling you and actually demonstrating with my bad math last week that I was going to need a little help with this whole marathon minute thing. So what we're trying to do is we're trying to convert how much activity we're doing as a school into energy that might mean something in the real world. And looking to see, like, you know, as a school last year, we did our marathon miles and we ran all the way across the country. Well, we're not running this year because of COVID. We're all at home and we're trying to do our own things to stay active. So over the next month or so, we're going to keep trying to stay active, and we're going to see just how active we can be and how much energy we can produce. So Mr. Fellman is going to talk a little bit about what energy is and what energy does and can do, and hopefully get into a little bit about green energy and how we're trying to take care of the world a little better with the energy today. And then Miss Lynn is actually going to help us crunch the numbers and do all that math so we can see exactly how much energy we've got. Hey, Mr. Fellman,
Hi.
can you take over and tell us a little bit about energy?
Yeah, thank you so much for reaching out to us. We love talking with you and talking to the elementary school students. At the high school, as physics teachers, we have a lot of fun. We do a lot of experiments, and we learn so much about the world. And it's usually looking at the ideas that we have, and then we'll solve problems. We see like how we can get to the bottom of something. And energy is a topic that my high school students love because in science, it's like a fundamental law that the whole world, the whole universe relies on. And this law is never broken. And every time we try to like delve deeper into it, we learn more about the world. So when you were talking about Marathon Mile and how it's related to energy, Ms. Lynn and I, we really became so interested in what you guys are learning about at the elementary school. So this law of energy, it's a fundamental law, and it's that energy can't be destroyed or broken, and it can't be made or created. There's like a constant amount of energy at all times, but it's transformed from one form to another. So you guys are running and you're measuring how much you're running. And in physics, we think about where does that energy come from? So in my house now, if the lights are on, I'm getting energy from NYSEG and they're delivering energy to my house. And my phone has a battery in it and I charge that up by plugging it in. So these things that we use, these technologies that we use, and when I go out and when I run, that energy is coming from someplace. And actually, when I charge my phone, the electricity is coming from a source. It's either coming from natural gas or it's coming from coal. And those sources, natural gas or coal or gasoline, if I'm driving my car, that initially came from the sun because the sun is shining down on Earth, and then a plant grew many, many, many years ago. And that plant got compacted and stored as a source of energy, and it turned into gasoline, or it turned into coal, or it turned into natural gas. Nowadays, we have the option of, instead of like waiting millions of years for coal or natural gas, we have this huge, beautiful 2.3 megawatt solar farm right in Enfield, and it gives so many homes and our school energy that we need. And the science behind using the sun as a source of energy instead of like digging for coal in the ground, that was science that was discovered by this really smart scientist who had a lot of trouble with math. His name was Albert Einstein. And he was just like the most curious person in the world. And he came up with so much science because he really liked thinking about big ideas. And so when we're solving problems, that curiosity and that sense of wonder and identifying the right idea is a really good place to start. So We have all these different forms of energy. If I'm charging my Chromebook, it takes like 43 watt hours to charge my Chromebook. My cell phone takes 3,000 milliamp hours at 4 volts, which is also 11.9 watt hours. There's all these different types of units that we use in measuring energy, and we try to keep them separate and specific and appropriate. And when we're trying to figure out how much energy we're using when we're running our marathon miles, we use certain forms of energy. And Miss Lynn is excellent at doing the problem solving. So I'm so glad that she's here to help all of us. Hi, Miss Lynn.
Hi. So would you like to see the numbers? I just want to say first that math is definitely not my strongest suit. I know we often think about physics teachers and physicists as being really good at math, but to me, math has always been like a slow, deliberate, I just have to go step by step. And I just keep at it. Like anything you do, you just figure out how you have to get somewhere, and you just don't worry about how long it takes, and you keep at it and you get there. Mm-hmm. So I tried to crunch some of the numbers that Mr. Harrington gave me, and I'm going to show you the formula I came up with. It's kind of a general formula, so we could plug in things from other schools if we wanted to. And that's really useful, so we don't have to redevelop this thing again and again and again. And I also want to just say, I'm going to put up this nice, clean-looking thing, but really, I have papers here, like scrap papers with crossouts and things in the garbage. And, it took a while, and I'm still not, completely sure. But I think I've got it right. I'm going to present this little screen now. Let's see. Present. Yes. Share. Okay. So let me know when you can see that. Mm-hmm. Okay. So there's a lot of words on here, but I just kind of read it. This was just to help me keep track. So I was told that you use about 50 kilowatt hours of electricity to power your school every month. So that's how the energy company, NYSEG, the electric company, charges you for 50 kilowatt hours every month. So I was trying to compare that to your output during your marathon mile. Like, how much work would you, or energy, how much activity would you have to do, right, to get 50 kilowatt hours? So your school is the 50 kilowatt hours, and I was told on average you're doing 1 minute for every 5 calories used. So you use 5 calories every minute. So this is a number we could plug in for any school, and this is a number you could plug in for any school. And then the rest are kind of conversions. So I'm converting from seconds to minutes. I'm going to get rid of my my calories and convert that to joules. So joules is just another unit of energy. It's the one that physics folks like to use. And then when we get through all of these conversions, I ended up with 143, a little over that, hours of activities by students at the rate of 5 calories per minute to get to your 50 kilowatt hours per month. So 143 hours. So what does that mean? So if there's 188 of you, that's what I heard at your school, 188 of you, each of you would have to do 3/4 of an hour, so 45 minutes of activities per month to totally add up to the 50 kilowatt hours. Or what if it's just 20 of you, like one little class, right? Then you would have to, each of you, do about an hour and a half every week, which is only like 20 minutes a day. So I started thinking, well, we ought to put a treadmill in your school or a little bike and hook it up to your electric system somehow, like your solar system is, and you guys could run the school. You could take turns on it. So I thought that was pretty neat. And also, I know that there are some countries that don't have like NYSEG like we do. They don't have like you can just plug into the wall, and they have wells for water. And in order to get the water up, you need a pump. But they don't have an electric system to run their pump. So they have bicycles set up, and they take turns and they power the pump in that way to get water for the whole community. So you can do these kinds of things. So I just wanted to show you one other little thing. So this is, again, a lot of words, but I was looking at a 60-watt light bulb and how much energy it took to burn that thing to have it lit for an hour. And it's a big number. It's about 200,000 joules, this unit of energy. But at 5 calories per minute, you output about 1 million joules in an hour. 1.2 million joules. It's a lot. So you could light about 6 of those bulbs for an hour. But we save a lot of energy using LED bulbs. We don't use as much energy as Mr. Feldman was saying. And an equivalent bulb that's an LED bulb like you have in your schools now, you could burn 39 of those bulbs for an hour and keep them lit with the same amount of energy. So that's pretty cool. I know I've switched to, and a lot of businesses have switched to LED bulbs for that reason. Okay, so I'm going to hand it back over to Mr. Harrington.
Wow, that's really cool. Thank you so much to both of you for the little bit of a lesson on energy and our thinking about it, and for those conversions. So it looks to me like that's a formula that I could use moving forward to continue thinking about the amount of time that our students would have to be active to power just about anything, right?
Yeah.
Because you've got all those long numbers, but the majority of it is really about converting, and what it's going to give me every time is how many hours of activity my students have to work to do whatever that initial number is. Is that right?
Yeah, absolutely. Yep. You can just use it over and over, and you could compare it to some other school. Maybe there's a school where the kids aren't as, maybe they only get 4 calories per minute, where you guys get 5 or 6.
Well, thank you so much. I really appreciate it. And the thing that I really wanted to point out was that we've talked about, and that my students have heard me talk about before too, is that this kind of thinking is really just about curiosity. It's about wanting to know more about the world around us, and that it's available to all of us. And I've shared before with them that math is not my strongest suit, but it sure is interesting to me. And I feel really lucky to have friends around me who can help me understand it better.
Well, thanks a lot for this opportunity. And, maybe we'll see some of you guys at the high school in a few years. That'd be great.
Yeah, I can't wait to have the curious students in my classroom. Have a great weekend, everyone.
Thank you both. Bye, Enfield.